Hello everyone and welcome back. So let's continue our discussion from the last video. What we are trying to do is to use the error bound formulas. We need this k value. Right now we are figuring out a method, or we are looking at different types of functions, and based on those functions we are looking for a way to find k. Okay, I'm teaching you how to find k. Now we learned about 3 easy examples in the last video. Let's turn into a complicated one. The function is cosine x square. You are integrating between 0 and 1. So a is 0, b is 1, and you use 10 rectangles, and let's say you use a midpoint rule. Okay. Alright, now the x window that we are working with is x values are between 0 and 1. We don't care what happens outside this interval. Okay, so the window that we care is between 0 and 1. Right, we know the definition of k is that it's the bound for the absolute value of the second derivative of the function. Now to find k, we have to find the second derivative of f. Let's do that. The first derivative of cosine x square, you have to use the chain rule here, right? Derivative of x square is 2x times the derivative of cosine is sine, so sine x square and minus, right? So that's the first derivative. Great. The second derivative is, now you have to use product rule. If you differentiate negative 2x, you get negative 2 times sine x square and minus now you differentiate sine x square. If you differentiate sine x square, you get 2x. That 2x and this minus 2x is minus 4x square, and sine differentiated will be cosine x square. Now I did this fast, but this is a combination of product rule and chain rule, so do that slowly. If you cannot remember, review your differentiation notes. Okay, now this is the second derivative. Now look at this. It's not just a single expression, it's just two-term expression, right? Not simple like in last video. Now k means the absolute value of minus 2 sine x square minus 4x square times cosine x square. So we take the absolute value and we want to find a value k that is larger than this function here between the x values. Not for every x value, but for the x values between, I guess, 0 and 1, right? That's what I said. Let's see. Yep, between 0 and 1. Right. How about if we graph this? Now, if you're doing homework, if you're working this problem at home, well, go ahead and graph it. Use Mathematica or use any other online graphing tool and graph it. So let me show you. These are the examples from the previous video. So if I graph that function, what I'm going to get is this. Okay, look at this graph. Now if you look at the graph, it seems to be like it's increasing for a while, but if you look closely, it's starting to turn around, turn back. It's starting to, like, it seems to be like it's going to decrease. Let's see, let's increase the interval from drawing interval between 0 1 to 0 2. I know we only care about what happens between 0 and 1, but I want to show you that it's actually going to decrease. Look at this. It's going until 1 and then increase. Little bit before 1, it's starting to decrease. Okay, so the point here is, before the x value gets to 1, it's already starting to decrease. That's what happens here. So really, this is not a strictly increasing function. There's a little dent before x reaches 1. Okay, so we want to find that. Now here's the thing. There are two things. Now, if you're doing this problem at home, like your homework assignment or something, okay, you should definitely figure out that maximum value using a calculator or a graphing tool, okay, because we want to find the k value accurately as possible. But I want to tell you there's another way we can find this k value, another k value, but that's not so accurate. But if you're doing like an exam, if you don't have a calculator, that k value works. Okay, all right, so I will show both, then it will make sense. Now how do you find this maximum? So what I did is I use Mathematica. Okay, you can use calculator, so I asked Mathematica to find the maximum for me. So find the maximum of this absolute value function between x value 0 and 1 starting from 0. So what is the maximum? Let's see. So Mathematica tells me you get the maximum at 0.994103. See what's going on? Just the x value reach 1, just before x value reach 1, there's a slight dent because the maximum is at 0.994. And that maximum value is 3.84, let's say after rounding to 2 decimals. So 3.84 is the maximum value occurring at 0.9. After 0.9, it's starting to decrease for a small while until 1. So really, this is not a strictly increasing function. There's a small dent. How do you find that maximum? Using a calculator or a Mathematica. So K value here really is 3.84. Does that make sense? Okay, so if you zoom out there, here like you have something like here, and this occurs at 0.9 and this is 1. So really, unlike our problems in the previous video, we cannot just plug 0 or 1 to the second derivative here and find K. Okay, because at that point, at 1, like at x is equal to 1, you don't get the maximum. Okay, because it reached the maximum just before 1. Okay, all right. Now you can certainly find this maximum if you're at home, if you have a calculator with you or Mathematica or any other graphing tool. But how about in an exam where you don't have the calculator? What can you do? Well, now here's the thing. What we can do is, if you're in an exam, there's no way, I don't think you have a way to find the maximum or that get this 3.84 value without a calculator. Okay, so we are not going to get that 3.84. We are going to get a different K value. And then that's not the ideal K value, but since you do not have any tools, that will work. Now, even when you're looking for a not so accurate K value, you have to find the best possible scenario. What we can do is we can factor this negative, so then absolute value will make it positive. So what we get is 2 sine x square plus 4x square cosine x square. So here's what I'm going to do. To find a not so accurate K, but a K value that still works, we have to find the maximum, right? Now think about this. I said sine values are between -1 and 1. So the maximum this term can get is 1. Right now, what I'm going to do is I'm going to look at this whole expression term by term. So first I'm looking at 2 times sine x square. Sine x square, the maximum it can get is 1. Okay, no matter what x value. So 2 times 1, 2. So that's the maximum that can happen from this term. Now if you look at this term, cosine x square, from cosine x square, maximum it can get is actually 1. Right? So it's 1 times 4x square. Now what is the maximum x can get? The x can get maximum is 1, right? Because we are working with x values between 0 and 1. So it's actually 4 times 1 square is 1. 1 times 1 is 1. So 4 times 1 is 4. So this is what we get. 4 plus 2 is 6. So K value is 6. Okay. Now what happened here? What I did here is I analyzed this function term by term and try to find upper bound. Now as you can see, K is equal to 6 is not a good upper bound, but why? Really this function is less than 3.84. So 4 is a better upper bound, 5 is a better upper bound. But why 6 is good if you're doing it in an exam? Because it has a logic. We use a valid logic here. Okay, so it's 2 times sine x, we argue that sine x square, the maximum it can get 1. So 2 times 1 is 2. So it makes sense why we get 2 here. Cosine maximum it can get 1 and x maximum it's 1. So it makes sense why it's 4 here and 6. Why we get 6. And is the function less than 6? Of course, yes. Right? So that's how you would do this problem in an exam, for example. Okay, but if you are doing this as a homework problem, then definitely you should try to find this 3.84 value by graphing it or by using a calculator. 2 different K values, but both of them serve our purpose depending on the situation. Okay, all right, let's move on to another complicated, tricky example. Okay. we have to integrate this polynomial between 2 and 3. So the x value, the x window we are working is from 2 to 3, and we are using n is equal to 10. But here in this video we only focus about finding k, right? Now here's the function. Definitely we need to find the second derivative. The first derivative is, if you differentiate once, it's negative 4x to the 3 over 12. Here 3 times 5 is 15 over 6 x square minus 3 times 2 is 6x. So that's the first derivative. The second derivative is that you differentiate once more. 3 times 4 is negative 12 x square over 12. Here 15 times 2 is going to be 30 x over 6. Derivative of negative 6 is negative 6. Now 12 cancel out, 30 cancel out, and we get negative x square plus 5x minus 6 as the second derivative. Okay, all right. Now k means the bound for the absolute value of this second derivative. Okay, now what do you think? Is this an increasing function or a decreasing function? Let's say you don't have a calculator and you're doing this at an exam. Now some would say, well, because of the negative in front of x square, it's a decreasing function. Some would say this is an increasing function. Let's plot it out, because this is a tricky one. Okay, where is it? Okay, so here we go, the function, and I'm going to plot it. See what happens. Now this is a parabola. Now it makes sense because that was a quadratic function, right? A function like ax square plus bx plus c. So again, this is increasing for a while and then decreasing. So I'm plotting this between 2 and 3. Okay, so it seems to be like the maximum never occurs at 2 or not at 3. The maximum occurs at somewhere else. How do you find that maximum? Well, it seems to be like it's 0.25, right? If you have a calculator, if you have a graphing tool, if you're working this at home, you can find that out using the graph. It seems to be like it's 0.25. But how would you, let's verify it. So I asked Mathematica to find it. Yes, it's 0.25 at x is equal to 2.5. So when x is equal to 2.5, you get the maximum 0.25. So that's your k value, because the graph, the absolute value of this function, the absolute value of negative x square plus 5x minus 6 gets the maximum at 0.25 between x values and 2 and 3. So that means the function is less than or equal to 0.25. The function can be equal to 0.25, that doesn't matter, but the other values are less than it, right? So k is 0.25. That's good. Now that's how you find it graphically. If you are interested, stay with me and see how would you find it if you don't have a calculator. If it is like an exam, if your instructor like to give a very tricky question to test your pre-calculus and calculus 1 knowledge, this is a good one. Like you have to find the maximum, right? How would you find the maximum of a quadratic function? How would you find the location that maximum occurs? There's a formula. The maximum or minimum of a quadratic function occurs at negative b over 2a if you have a quadratic function ax square plus bx plus c. Okay, so here b is 5, a is negative 1. So x is actually negative 5 divided by negative 2, because a is negative 1. So the maximum occurs at 5 over 2, 2.5, and which makes sense because Mathematica told it to us, right? Now the maximum occurs at x is equal to 2.5. So what is the maximum value? How can you find the maximum value? Well, just substitute 2.5 to this function, negative 2.5 square plus 5 times 2.5 minus 6. If you do that, then you would get 0.25. Okay, so that's how you would find the maximum of a parabolic function. So if your original function gives a second derivative of a parabolic function, then this is how you would solve the problem. This is how you would get k. Now here for the k value, yes, now you don't need a calculator here. If this is given in an exam, not in an example, in an exam, you should be able to find this 0.25, I would say. Okay, so my numbers are not nice, so you would get a problem where numbers are nice and you don't need a calculator to do simplifications. Okay, so but I wanted to show you an example where it's neither it's not purely increasing or strictly decreasing. There's a turnaround and how you would find that. Okay, all right, so that's how you would find K for different types of function. We looked at increasing, decreasing and oscillating functions, and we learned how to find K. We still didn't solve full problem with error bound question category. So starting from the next video, I'm gonna show you how to solve a full problem and how to analyze from there, because now we know how to find K. So I hope that you shouldn't have any problem with K. Okay, all right, so I'll see you in the next video. Bye bye.